So as I mentioned before, we're going to look at butane. So here's our butane. Typically with something like butane, instead of looking down the 1, 2 axis, we will look down the 2, 3 axis. So let's draw in our hydrogens. And our eyeball looking down that 2, 3 axis. So in this case, if we're going to draw the first one, we have a carbon atom with 2 hydrogens pointing upward and a methyl group on the bottom. And on the back carbon, we have our methyl group pointing up and our 2 hydrogen atoms pointing down to the left and to the right. This is going to be our lowest energy state. Why do I say that? There's no eclipsed interaction, so there's no strain resulting from the hydrogen atoms being too close. And the 2 methyl groups, which are the largest, are as far away from each other as they can possibly be. We call this type of conformation an anti-conformation. So let's spin this 60 degrees and see what happens. I'm going to draw it up here a little bit higher so we have some room. We're going to keep arbitrarily our front carbon locked. We'll spin the back. Our methyl group is going to move, so it's now eclipsed with the hydrogen. This hydrogen will shift over, so it's eclipsed with the other methyl group, and the other hydrogen will just be eclipsed with the hydrogen. So if we add these up, we have an eclipsed methyl hydrogen, an eclipsed methyl hydrogen, and an eclipsed hydrogen. So we add those up, we get 6, 12, 16, which I have right here. This is our eclipsed conformation. Eclipsed conformations are always going to have higher energy than staggered conformations. Spin it around another 60 degrees. Again, we're going to keep the front carbon locked. The methyl group relaxes from being eclipsed to this staggered conformation. Everything spreads out a little bit more, so we know it's going to be lower in energy. But in this case, the 2 methyl groups are relatively close to each other. Instead of being in an anti-conformation, we call this gauche, which is when 2 substituents are close to each other. Gauche interactions result in, for methyl groups at least, a 3.8 kilojoule per mole energetic penalty. They're too close to each other. That'll be right here. So let's connect these lines as we go. Next, another 60 degrees. Going to keep the top or the front the same. We're going to spin the back carbon again. So we go from this gauche interaction to an eclipsed interaction in all 3 cases. Now we have 2 eclipsed hydrogens, so that's 4 plus 4 is 8. And the methyl groups now are eclipsed as well, which has a much higher energy because, again, methyl groups are larger. So we're up to a total of 19 kilojoules per mole. So I'm going to draw a line right here. That's our highest energy conformation. Relaxing back down another 60 degrees, you should recognize we're going to go to one of the staggered conformations. Keep the front carbon the same. This methyl group will be here. Notice it's still gauche, but at least it's not eclipsed. That gauche interaction gives us a 3.8 kilojoule per mole energy difference. If we rotate again, we're going to get another staggered conformation. Or another eclipsed conformation, I'm sorry. Where we have 2 hydrogen methyl eclipsed conformations. That's 6, 12 plus 4 more here gives us another 16. And if we rotate it again, we go back to our anti-conformation, which we originally drew here, which is our lowest energy state. So what you should be able to do with this is if I give you these values up here, you should be able to draw a conformational energy map. You should be able to assign anti and gauche conformations. You should be able to assign staggered and eclipsed conformations. If I don't give you the energetic values, you should be able to reason out that larger substituents are going to have higher energies. They're going to have higher conformational energies. So if I gave you 6 Newman projections and asked you to rank them in order of highest energy, you should be able to do that. If I give you a curve like this and I label the points A, B, C, D, E, and F, you should be able to match these energies with the various Newman projections that I might give you.